Hello guys, welcome to learning microcontrollers. In this video, we are going to start our new series on Arduino UNO. So this will be the first video in which I will give you a basic introduction to Arduino UNO. Then we will move on to future complex projects, easy projects and every type of project with Arduino UNO as well, like we are doing with the PIC. So let's get started. So guys, this is our Arduino UNO. It's very easily available in the market and you can see that it's a well familiar name, and this board is the Arduino and the microcontroller on it is 80 mega 328 bit. Total it's like Arduino UNO board. So you can see that this chip over here, it is the main player in this board. This is the microcontroller called 80 mega 328p. It is also available in the assembly forms as well, and this one is the DIP variant. And if you install this assembly on a board, you get an Arduino Nano. So in short, Arduino Nano and UNO are same boards. One has 80 mega 320p 28p in DIP form, and Arduino Nano has the same microcontroller in assembly form. So they both will have the same capability. So let's move on. So guys, this is our Arduino UNO board, easily available in the market and very cheap as well and very powerful as well. So let me introduce you to its a flash memory. It has a 32 kilobyte of flash memory, which is huge at such a cost, and it has a 16 megahertz crystal installed on the board. You can see that this crystal over here is 16 megahertz, and then this means that it can generate a speed of 16 million instructions per second at a 16 megahertz crystal. So this is a very fast speed. It's a very good microcontroller speed wise as well. Then guys, it's a 8-bit microcontroller, and this is important. When we will do the programming, you will know what 8-bit means. Now guys, let's move on. First of all, you can see that this port over here, it is a jack port. You can simply connect an adapter jack, DC power supply jack in it, or you can connect that jack to a battery, but maximum voltage would be like 7 to 12 volt, and there is a 7805 regulator on this board which will auto convert that voltage to 5 volt, and another regulator AMS 1117, it will convert this into 3.3 volt. So you only have to input like 7 to 12 volt, and it will auto convert that to 5 volt and 3.3 volt, which your sensors and modules connected to the board will require. So you can also give them as output. So this board will also act as a power source. So you only need 7 to 12 volt VDC input, and then it has two voltage regulators, one for 3.3 and one for 5 volt. That's all. Then guys, you can see that we have like 4 points for power: 3.3 volt, 5 volt, 5 volt, 5 volt. These are pins, and you can take the output from there for any sensor module as you want. Now guys, this V-in pin is different. Here you will give the V-in voltage, that is your 5 volt over here. Then this voltage will pass through the voltage regulator, and then it will become 3.3 volt. So that will be safe. Instead of plugging in a 5 volt source directly at the 5 volt, you always plug it in at the V-in. So it can be converted into 3.3 as well. So that's a proper way of doing it. So these are the grounds: 1, 2, 3, 4, 5 ground pins, and then there are several other grounds which you can hold wires at them. But these are the grounds open for you. You can use them for any sensor and module as you like. Now guys, this over here is the programming port. Your cable will come from the computer's USB port to the Arduino UNO, and it will be connected at this point. So this is your programming port basically. Now guys, this is so we have total of 6 ADCs. These are the ADC pins: A0, A1, A2, A3, A4 and A5. And the good thing is, ADC resolution of Arduino UNO is 10-bit, that is 0 to 1023, that is 2 power 10. So it's a very powerful ADC, I will say, and it has total 6 channels. Now guys, the next thing is the hardware UART. UART stands for Universal Asynchronous Receiver and Transmitter. It is one of the most used port in the world nowadays, and it is very fast and very powerful and very easy to use as well. So you have only one UART port in Arduino UNO, and UART requires 2 pins to operate. These are the TX and RX. They are located here. Pin number 0 is the RX and pin number 1 is the TX, like this. Now guys, other than this, Arduino is well known for software serials. Software serials are the software UART. They don't require the hardware. They use the some sort of, you can say that, libraries to use the same hardware to generate multiple UARTs. You can use them on other pins as well, but they are not as efficient as this hardware UART is. You will see them whichever library you use for the software serial, and you will go to the description of that library. You will see that it has certain limitations, like you cannot set the baud rate above 38,400, or you cannot connect them in parallel. They will work one at a time only, like that. So, but for now you must know that hardware UART is only one. Then we will also do programming using the software serials. They are very good and they have great applications. Now guys, the next thing is the SPI port. It stands for serial peripheral interface. And guys, you only have one SPI port on your Arduino UNO 80 mega 328p. Another one is also there, this one, but this is for some other purpose. Let me tell you what is the purpose. So first of all, SPI requires 3 pins to operate: SCK, MISO, MOSI. On Arduino UNO, they are located at pin number 11, 12 and 13. Now guys, you have a duplicate of same port over here. These 6 pins here, 13, 12, 11, they are the same pins. 13 is SCK, 12 is MISO, 11 is MOSI. They are exactly the same, just a duplicate over here. So you can use these as well, you can use these as well. Now guys, the next thing is your second SPI2. This is for ICSP purpose for other older versions of 80 mega microcontrollers. So you will not be able to program them using this 80 mega. They will be used for other purposes. So just forget them. For now, to utilize the capability of 80 mega 328p, we do not need them. Neither we can use them. So you have only one SPI. Then guys, for the I2C pin, that stands for inter-integrated circuit. This requires only 2 pins to operate, or 2 wires to operate. They are named as SCL and STA, and they are located at pin number A4 and A5, like this over here. You can see that. Now guys, the point is you also have a duplicate of I2C port as well, that is over here. This SCL and STA, this is A5 and A4, they are the same thing. This is just a duplicate. You only have one I2C port, but there is also a duplicate of it as well at this point. Now guys, the next thing is the PWM pins. PWM stands for pulse width modulation. It is very useful, especially for controlling the speed of DC motors and for also controlling brightness and dimness of LEDs, etc. And they have other tons of application when you interface other sensors and modules. So the good thing is Arduino UNO has 6 PWM pins, and this is a huge number. And 2 pins, that is pin number 5, located. You have 6 pins located at pin number 3, 5, 6, 9, 10 and 11, like this. Then guys, the 2 pins that are pin number 5 and 6, they support frequency of up to 980 Hz. While rest of the 4 pins 3, 9, 10, 11 supports frequency of up to 490 Hz. So these are very good frequencies, and pin number 5, 6 are very powerful PWM channels. So the next thing is the external interrupt. Your Arduino UNO supports only 2 external interrupt pins. These are at pin number 2 and 3. This is some complex thing, but we will use them in our programming in the future videos, and I will show you how to use them. Then guys, you have total 3 timers in Arduino UNO. They are timer 0, timer 1 and timer 2. Timer 0 and timer 2 are 8-bit, while timer 1 is a 16-bit. Then guys, as you know, this is our Arduino UNO. Then the great thing about Arduino is its programming software called Arduino IDE. It's an open source free software, uses C++ programming language. So guys, this programming tool will give you a great edge over other microcontrollers because it has tons of libraries available on the internet. You can simply download and use a library, but my approach will be different. I will show you how to make a library, how to use your own techniques by reading the datasheet of sensor and modules and make a library. That's what I will teach you. So guys, this is it. This was some basic introduction to Arduino UNO. I hope you guys learned something from this video. If you have any questions, you can ask in the comments sections. And thank you very much for your time, guys, and we'll see you in the future videos.